Lesson 8.1, Sample Spaces and Probability. A sample space is the set of all possible outcomes in a probability experiment. For example, if our probability experiment is flipping a coin, our sample space will be either heads or tails. An event is a wanted outcome, like getting a heads. The actual outcome is what happened, like getting a tails. Alright, so let's try page 408, number 2. Find the number of possible outcomes and then list all the possible outcomes. Well, the easiest way here is to make a tree diagram. So we have, say, coin 1, which could be either a head or a tail. Then we have coin 2, which could either be a head or a tails, or a head or a tail. And then coin 3 could either be a head or a tail. And we're making this head and tail off of each of our options. And then coin 4 is either a head or a tail. And you can see at the end here, at the bottom of our tree diagram, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possibilities. So the number of possible outcomes, well, our first coin had 2 options, our second coin had 2 options, our third coin had 2 options, and our fourth coin had 2 options. Multiply all together, you get 16. So to get the total number of outcomes, just multiply together the number of outcomes for each individual event, and that gives you the total. Now to list our sample space, we can go along and do each of our things in the tree. So we could have head, 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 head. Or we could have head, 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 tail. Or we could have head, head, tail, head. And that's different. And then head, 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 tail, tail. That would be this one. Well, now we're over here, so we have head, tail, head, head. Head, tail, head, tail. Head, tail, tail, head. Head, tail, tail, tail. Okay, that's our first 8. And now we're over here, so it could be tail, head, head, head. Tail, head, head, tail. Tail, head, tail, head. Tail, head, tail, tail. Tail, tail, head, head. Tail, tail, head, tail. Tail, 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 head. And finally, tail, 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 tail. Look at that, 16 options. No 2 of them are the same. They're all different from each other. Those are all the possible outcomes. So then we could do things like find how many different ones have only one head or whatever. Why don't you try number 1, 408, number 1. This time we are flipping a coin and drawing a marble. So for a coin, we could have either a head or a tail. For the marble, we could have a purple, 2 purples or a white. So purple, purple, white, and purple, purple, white. Now it's 2 purple marbles, so we labeled them twice. So it looks like we could have head with the purple, or we could have head with the other purple, or we could have head with the white. We could do tail with the purple, tail with the other purple, or tail with the white. And so you have 6 options. You had 2 for the coin and 3 for the marble. It was used 6 options. So what are you going to do with this sample space? Well, we're going to use it for probability. Probability is a number between 0 and 1 to indicate how likely something is to happen. If you get a 0, it can't happen. If it's 1, it always happens. And so like if it's a half, then it's 50% likely to happen or not happen. If it's 25% or 0.25, it's just unlikely, and so on. So how do we calculate probability? Well, we have theoretical probability, which is the number of ways event A could happen over the total number of possible outcomes. Notice this number here, this little letter, that is your event. So the P stands for probability. And then A is the event. It's not P times A. It's probability that event A occurs, the number of ways A happens over the total number of possible outcomes. Alright, so let's try an example. You flip a coin 4 times. What is the probability that the coin shows head exactly 3 times? Alright, so we want the probability that we get 3 heads. So that would be the ways to get 3 heads over our total ways. Now this was off of our first example. So the ways to get 3 heads, we could have heads, 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 tails, heads, heads, tails, heads, heads, tails, heads, heads, and tails, heads, heads, heads. So that's 4 options. If you need to, you can go back a couple slides and look those up when we made the sample space. And in that same sample space, there were 16 total outcomes. Remember, it's 2 for the first coin, 2 for the second coin, 2 for the third coin, and 2 for the fourth coin, which makes 16 total ways when you multiply it together. Well, 4 over 16 is the same as 1/4, or 0.25. So is that likely to happen? Nope, not likely to happen. Why don't you try number 5? Game show airs 5 days a week. Each day a prize is randomly placed behind one of 2 doors. What is the probability that exactly 2 contestants guess the correct door during a week? Pause it while you solve it and then come back. Alright, turns out it's a very long option. You have the number of possibilities. On day 1, you have 2 options. Day 2, you have 2 options. Day 3, you have 2 options. Day 4, you have 2 options. Day 5, you have 2 options. Choose your 32 total options when you multiply those together. Now, how many have 2 wins? Well, you could do win, win, loss, loss, loss. You could do win, loss, win, win. Sorry, win, loss, loss. You could do win, loss, loss, win, loss, win, loss, 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 win, lose, win, win, lose, 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 win, lose, win, lose, and lose, lose, win, win, lose, and lose, lose, win, lose, win, and finally lose, 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 win, win. And I missed one. We missed this one. Lose, win, lose, lose, win. There we go. So, our probability that we get 2 wins. Well, how many ways could we get 2 wins? Well, if we count them, there are 10 ways to get 2 wins. How do I know? Because I counted that from my tree diagram out of 32 total ways, which gives me 5 over 16, which is 0.3125, which is not likely to happen, but it's more likely to happen than the coin example. All right, let's try another one. 2 D6 are old. Okay, D6 is a 6-sided dice. What's the probability of rolling a sum that is not 2? Well, we need to find out all our sums, so we can make a little diagram here. So we have dice 1 and dice 2, and so these are all the options. The white dice has all the numbers 1 through 6. The red dice has all the numbers 1 through 6. We want the probability the sum is not 2. Well, it looks like there are 36 total options, and the only one that sum is 2 is that first one right there. So the probability, we're going to use the symbol not, would be, well, there's 36 total and one of them is the 2. That means we'd have 35 that are not 2 out of our 36, which is about 0.972. So that is likely to occur. Let's try another one. It's a probability that the sum is less than or equal to 10. All right, so the probability that a sum is less than or equal to 10. All right, adding up to get 10 is all of those. So it's actually all but 3 of them. So it'd be 36 minus 3, or 33 out of the 36, which gives us 0.917. Why don't you pause this and try number 7. Probably it's not 4, and then greater than 5. First one is about 0.92. The second one is about 0.72. Let's try an example using geometry. Number 12. A student loses his earbuds while walking home from school. The earbuds are equally likely to be at any point along the path shown. What's the probability the earbuds are on Cherry Street? All right, so the probability that we're on Cherry Street would be the length of Cherry Street over our total length. Well, Cherry Street appears to be 0.2 miles. The total appears to be 0.1 plus 0.4 plus the 0.2 from Cherry Street. Or in other words, 0.2 over 0.7, which is 2/7 or about 0.286. Not likely that it dropped it on Cherry Street. Why don't you try number 11? This one's using areas. Find the probability of randomly choosing the yellow area. All right, you're going to pause this while you solve it. I can help you out a little, though. The probability of the yellow would be the yellow area over the total area. All right, but the yellow area, that one's going to be fun. The yellow area appears to be a circle, a yellow circle with a radius of 9. So it'd be pi times 9 squared. But then we have to subtract the stuff inside. Well, the white square with the yellow circle, or the red circle, that. It's just a square with 6 inches in each side, so we could just subtract the area of that square. But we also have the two triangles, the two green triangles. Well, the triangle's area is 1/2 the base. Let's use this as the base. That's 6 times the height. Let's use that. Well, if the all the way across is 18, in the middle is 6, that would be 6 and 6 to make our 18, so it appears like the height is also 6. Our total area is 18 times 18. So that gives us 182.5 on the top approximately, and 324 on the bottom. When you divide that, you get about 0.563. We also have what's called experimental probability, which is probability based on the results of an experiment. Theoretical probability is we think and say, oh, this is what it should be. Experimental probability is, oh, here's what we actually did, what were the results. Each section of the spinner shown has the same area, so that means it's equally likely to get any spot. The spinner is spun 50 times. The table shows the results. For which color is the experimental probability of stopping on the color the same as the theoretical? Well, if they're all equal spaces, the probability, theoretically, of any color is going to be 1 space out of 5, or 0.2. So for each of these, we can try the experimental probability. For red, it was 5 out of 50, which gives us 1 out of 10, or 0.1. For green, it would be 20 out of 50, which is 2 out of 5, or 0.4. Which is way higher than what it ought to be, right? It's like double what it should be. Blue is 3 out of 50, which gives you about 0.06. Yellow is 10 out of 50, which is 1 over 5, which is 0.2, and you can see we just got our answer. Purple is 12 out of 50, which reduces to 6 over 25, which gives us 0.24. So which one is the same as theoretical? Appears to be yellow. Why don't you try number 13? Pause this while you do it. The answer is blue is higher.